Hello and welcome to the Azure Administrator AZ-103 training course. This is Module 1. In today's module, we're going to go through a set of introductions and the setup you need to get prepped to run the course and to go through it. Then we're going to take a look at objective number 1, which is all about deploying and managing virtual machines in Azure. Once we've done that, I'm then going to go through a demo of creating virtual machines in Azure, configuring them, configuring backups, and configuring Site Recovery Manager. Then, in the labs, we're going to build on the knowledge that I've covered in this module and give you the chance to go and get your hands dirty building some virtual machines of your own. Unlike the previous course, where most of the exercises were just done in the Azure portal, this time we're going to get a chance to go back and actually do some exercises where not only do we build things in the portal using the graphical user interface, you'll also gain some very valuable hands-on experience of configuring things through the Azure command line interface and through using the Azure PowerShell modules. If we want to do really well in this exam and pass it, we have to be ready for it. That means we know the subject, we understand the subject, we feel like we understand the subject and the exam we're going to sit, and also we're aware of what the exam testing experience is going to be like for us. So, how are we going to go about getting you guys ready for the exam? If you come along and sat the AZ-900 course with us, this slide will look very familiar for you. If you haven't, if you already have some experience with Azure, you can probably just jump in on this course at this point and you'll probably be all right. But if you do that and you find that some of the concepts I'm talking about, you don't fully understand them, feel free to go back and look at the training materials for the AZ-900 course. There's recordings and there's the PowerPoint and the lab exercises, and they're just in the next folder along from this course in the team site. I'd highly recommend you have a go at the AZ-900 exam. Not being AZ-900 certified won't stop you from sitting the 103 exam. What it will do is help you cement the fundamental knowledge that's going to build upon that not only is the 103 exam, but this 103 course will build upon. As part of this module, we're going to take a look at the exam objectives. It's really important that you're going to understand, the subject. You need, before you start learning this stuff, you need to know what it is you've got to learn. So let's do that in this module. Also, in modules 3 and 4 of this course, we're going to take a look at the actual exam structure itself. We'll take a look at the type of questions you can be asked, and we'll explain the new Microsoft labs that will happen in the exam, where you'll be actually expected to build out a solution in the exam. Now, don't get too worried about that. The sort of things they ask you to do are fairly simple. We cover them all on this training course. And if you've got any real experience with Azure, it's not too problematic at all. The exam itself is quite forgiving. You can make mistakes, and as long as the end result meets that you put in place, meets what the exam meets what the lab requirements ask you for, you're going to get the points for it and you're going to pass. Right, hands-on experience, right? This has never been more important. There's 3, maybe 4 sets of labs we're going to put out with this course. Make sure you don't skip on doing them. The labs that you're going to find in the exam, you'll probably find it quite familiar to the lab exercises we're going to do in here. I generally guarantee you, if you haven't got hands-on experience with Azure, you're not going to do well at this exam. With the right level of experience, which isn't that deep, you're going to have the confidence to be able to go in there and do quite well this exam. So please, please, please make sure you do the labs that we're prescribing in this training course. Once we've been through the various modules, go back and look at revision notes. As we're going through, create your own revision notes, either from this training, go away, do some online reading. I'm going to produce a set of revision notes that'll be available at the very end of this course. Go back, because the reason why I'm putting them out at the end is I don't want you not to make your own revision notes. I don't want you to feel like you don't have to pay attention. I don't want you to feel like you haven't got to make your own notes. Make notes. The act of just writing something down helps you remember it, and it helps to make that knowledge a bit more subconscious as well. So make your own revision notes. At the end, come back and compare yours to mine. Compare your revision notes with those of your colleagues who are also sitting this course. Then, what we're going to do towards the end is readiness review questions. The last module of this course, we'll go through some sample questions, and we'll go through some sample lab exercise objectives. You'll get a feel for the sort of thing you're going to be asked about. One of the things I don't think we've got funding for as part of this training, but if you speak to your line manager, you might be able to get, is the readiness review tests produced by a company called MeasureUp. They're certified by Microsoft as exams that will help you prepare for the exam without cheating. Finally, the difficult part, actually sitting down and doing the exam. It's a 3.5-hour long exam for AZ-103, but count yourself lucky. When I first sat in an Azure infrastructure exam, not only did I have to learn a lot more content, the infrastructure exam wasn't just focused on infrastructure as a service, which this exam is. You used to have to know a lot about platform as a service. You had to know a hell of a lot about scripting. You had to have a very, very deep understanding of application infrastructure as well. That's gone away now. The AZ-103 exam is very much focused on infrastructure as a service components and storage. So we need to make sure we structure our revision around that. The other thing with the exams as well, where they've gotten a lot easier, is not only have they focused on skills that are relevant to the certification. So if you're an Azure Systems Administrator, you're going to get questions geared towards systems administration, not development, not architecture, and certainly not deep dive DevOps or security. But try and remember the exam is very fair. Yeah, if you've gone through this preparation study and you've done the groundwork, you'll walk this exam. It's not the most difficult exam in the world. I'm seeing pass rates of, when I teach this course, normally there's about 12 or 13 people are in the room. They go in to sit the exam after they've gone through this preparation cycle. They go in there and about 9 or 10 out of the 12 people pass with a good score. And usually everybody bar 1 or 2 people get the exam on the first try. And pretty much everybody gets it on the second try. Why is that? Okay, if you go in there and you fail, it is not the end of the world. Learn from that failure experience. If you do go and sit the exam, feel free to send me a copy of your exam results. The exam results will have a set of graphs on it that tell you where you didn't score so well. And what I can do is I can give you some exercise, say go back, rewatch this module, go do this lab exercise, read these technical articles. Great, okay, hit the readiness review questions right now, go in there and do it again. I've probably taught about 250 people before the AZ-103 course so far. And out of those 250 people, about 235 of them passed the exam the first time, and everybody has passed it at least when they've done the second exam. So it's something that you can and you will pass if you follow this preparation strategy. Whereas the AZ-900 fundamentals exam covered a very large subject area where you were expected to be able to have awareness of knowledge and understanding of things, the AZ-103 exam focuses on several areas of Azure infrastructure as a service. Those areas are managing subscriptions and resources, implementing and managing Azure storage accounts, deploying and managing virtual machines, configuring and managing virtual networks, and using Azure Active Directory and hybrid identity to manage identities. So those are the areas we're going to cover off. Pretty much each one of those objective sets corresponds with a particular module on this training course. Don't worry, we're going to cover all of this stuff in the right depth, and you are going to go through some labs that really bring the knowledge you're going to get from these modules to life and turn that into some real experience. This pie chart shows us the weighting that Microsoft have given towards each of the objectives in the AZ-103 exam and the number of questions you're going to get. What you'll see from this pie chart is the green area of the pie is the biggest, and that means configuring and managing virtual networks is probably where you're going to face most of the questions. Pretty much the other 4 objectives, they're an even spread of about 15 to 20% of the questions that will come up on there. So what that means is make sure you pay extra special attention to the labs and the revision notes for managing virtual networks. Our first objective for the AZ-103 exam is to be able to demonstrate experience and hands-on expertise with deploying and managing Azure virtual machines. The deploying and managing virtual machines objective is worth roughly between 50 and 20% of the exam. So what you'll find is somewhere around about a fifth of the questions you're going to face are on these objectives. So in the remainder of this module, the following lessons we're going to do are going to drill into creating and configuring a virtual machine for Windows and Linux, automating deployment of virtual machines, deploying Windows and Linux virtual machines, and managing virtual machine backups. Now, you might be like me, where you come from predominantly a Windows background, and maybe you don't have too much hands-on experience of Linux. Don't let that put you off. Try and remember that this exam is focused on your ability to be able to deploy and configure virtual machine resources. Anything you face in the lab is probably not going to be about remote desktoping into something or using secure sockets host to send scripts to Linux machines. It is going to focus on your ability to create the resources that those Linux virtual machines run on. So don't worry if you're not an expert or even that familiar with Linux. I'll make sure that I teach you during this course the stuff you need to know about Linux and what you need for the exam. In lesson 1, we're going to drill into creating and configuring a virtual machine for Windows and for Linux. The individual components of this objective are that to pass the exam, we need to be able to demonstrate that we understand how to configure high availability for a virtual machine. We need to be able to demonstrate that we know how to configure monitoring, networking, storage, and virtual machine sizing. Also as well, we've got to be able to demonstrate a knowledge and principles of deploying and configuring Azure virtual machine scale sets. One of the fundamental principles of public cloud computing is about consistency. Unfortunately, what you can't do is come into Azure and specify, I want 7 CPU cores, I want 31.5 gigs of memory, and I want this hardware and that combination. Yeah, we can't do that. To keep things consistent and to keep it manageable, Microsoft have produced standard sizes of virtual machines. They've also gone a little bit further as well to divide out customized hardware platforms in their marketplace. So virtual machine sizes and pricing is driven by the type of virtual machine, which drives what type of workload you want to run on there, but most importantly, the size. The size of a virtual machine is about how much capacity you're going to buy from there. If you take a look at this slide here, what you'll see is when we go in to buy a virtual machine or to configure one, we have to choose a size for our virtual machine. If we shut down a VM under certain circumstances, it is possible to resize a virtual machine afterwards. However, when we after we've provisioned a virtual machine, there are going to be some changes from one size to another that won't be supported. For example, it's very difficult for a virtual machine to go from, say, having 32 data disks down to just having 8 data disks if you've got a bunch of drives in there that have been configured. So in some cases, resizing might need manual intervention. As well as providing VM sizes that ultimately determine how much capacity we're getting for our money, Azure also structures virtual machines into types. Now we have these families of virtual machine types that are pretty standard. So we have the A type of machine, or the A family. That gives us the lowest cost to run a virtual machine. That's ideal for kind of test and development environments, anything where we need to keep the costs down. The D series of machines adds solid state storage and very fast CPU for our workloads. So if we need huge amounts of throughput for storage and fast CPUs, that's the series to go to. Microsoft improved on the original D series or the D family of machines by creating D2 version 2 machines. They include some additional options in there as well. The G series of virtual machines gives us a high amount of memory compared to the number of CPUs and very large solid state disks. The F family of computers are intended for compute intense workloads. That means they have a very high CPU to memory ratio. So if we need something that's got compute horsepower, F is probably what we're going to choose. There are two N families. So we have the NC and the NV families of virtual machines. Now, what's special about those VMs is that they include graphics processor units in there. One of the things you're going to find is obviously the video game industry has driven a huge amount of innovation over the years. NVIDIA have specialized in creating graphics processors units, mostly for the video game market. But what we found over the last 3 or 4 years is we're starting to run like data science type loads that need incredibly efficient CPUs for performing high intensity and complex mathematical operations. GPU chips just work out being much more efficient at doing that for us. So what you're going to see in the Azure portal is these two VM families give us the ability to have a GPU chip in our machines. So those are ideal for any kind of data science or deep analysis type workloads. Also as well, servers and virtual machines with GPU processors in them are also incredibly useful for desktop virtualization scenarios like VDI. The H family of machines have the fastest CPUs at the moment. They're also optimized for inbound connectivity as well. So they've got teaming done on their network cards beneath the waterline. The L family gives us access to very large solid state drives. So if we've got something that's very, very heavy on performance of storage, that's a good choice for us. We've also got version 2 of the A series of machines. Now what they've done there is they've expanded on the limits of that the A version machines as well, giving us more options in there. But A is still intended to give us the lowest possible price options in there. One of the things you should be noticing there, so for example, the D series of machines and the A series of machines have version 2s. That means Microsoft have taken a look at that family and said, look, we'd get more business if we added some more functionality in here. So what they do though is they leave the original series in place. That way they can make modifications and make the new capabilities available without changing your current configurations that are in place. If we're working with Azure Virtual Machines, Azure gives us 3 options to obtain a Microsoft-backed service level agreement for the virtual machine. Now, for the sake of disambiguation, it's important to understand what that service level agreement gives us. Microsoft are only guaranteeing with that SLA that the virtual machine itself will be up and running. That means the operating system will be loaded. That SLA does not include any availability metrics for your applications that are running inside that virtual machine. So the SLA would be kind of like this. We guarantee your web server is up and available for 99.9% of the time. However, Microsoft are not making any guarantees about the code or the website that machine is writing because they haven't produced that. So the underlying VM is available for 99.9% of the time, but your code might break within that time. So it's important to understand these virtual machine SLAs are about the virtual hardware being available for a period of time. There are 2 ways to deploy hard drives in Azure. We have the traditional unmanaged mechanism, and what we used to have to do there is we had to create a storage account ourselves, and we had to choose which storage accounts to put the virtual hard drives we attach to our virtual machines to. That was okay, it was good, but a lot of people didn't understand that there were performance limits on a storage account that limited the overall number of input-output operations and also limited the amount of bandwidth that could flow into or out of a storage account regardless of how many virtual hard drive files you had in there. What I used to see in the early days of Azure, I'd go and see customers who were telling me, I've now got 10 VMs, it's all starting to grind to a halt. Yes, they had 10 VMs, they all had 10 separate virtual hard drives, but they put them all in the storage account and they were hitting the limits of the storage account object itself. So what we had to do in those days was instruct people, right, we need to get that virtual hard drive and move it into its own storage account and repeat and repeat and repeat. Okay, obviously that's not optimal. So what Microsoft did was they came up with this technology called managed disks. And what we do there is when we create a virtual machine or a virtual hard drive, Azure itself will automatically create the storage account type infrastructure that it needs to store that virtual drive in. What that means is because Azure is taking care of positioning the storage of those machines as it sees, what we wind up with is just an overall limit of input-output operations and throughput for each individual virtual machine. What we're doing there is working away from the limits on an individual storage account. This means we don't get those bottlenecks. What Microsoft have done to try and incentivize people to move away from having unmanaged disks to moving towards managed disks is Microsoft now offer a 99.9% SLA for virtual machine availability if you use managed disks. That means you can take one VM in Azure, as long as it uses managed disk for its storage, Microsoft are guaranteeing you the VM itself will be up for 99.9% of the time. Microsoft also provide a couple of high availability options that allow us to deploy multiple servers into an architecture. If you think about what we used to do with on-prem workloads, if we wanted to make SQL Server highly available, we'd deploy a cluster of SQL servers with 2 or more database servers in there. The same with web applications. We might deploy several Java servers, or we might deploy several IIS web servers and put a load balancer in front of it to make the machines highly available. We'll still work with architectures like that on infrastructure service as a service in Azure. We might still build a farm of web servers. We might still build certain types of SQL clusters in Azure. What we need to do is tell the people that are running the fabric where these virtual machines live that there is an availability relationship between 2 or more servers, which means they shouldn't take both of them offline at the same time. Microsoft does have to do some administration itself that causes virtual machines to be taken offline. Periodically, they have to replace hardware. Periodically, they have to service hardware as well. So that means we need to make sure that when we deploy multiple virtual machines as part of an availability set, we're telling Azure to make sure those virtual machines run on separate fault domains in the environment, meaning they run on independent hardware. So if Microsoft have to replace a physical server, yes, they may need to take my virtual machine down temporarily whilst they move it someplace else, but at least one of my VMs is going to be up and running. So an availability set is divided up into fault domains, and what we do is we ensure each machine runs in a different fault domain. Availability sets also have update domains. Now, update domains make sure that your machines are placed on servers that are part of a different patching cycle for the physical host. Microsoft has to patch the machines that our virtual machines run. The physical hosts must be patched by Microsoft. We get no access to the hypervisor host, so they have to do that for us. But they've put an absolute ton of stuff into the version of Hyper-V and Windows Server they run this stuff on. There's minimal amount of code on there, so there's a minimum footprint of software updates are required on there. They've also done something clever as well to reduce the number of updates that the Hyper-V service itself needs. But occasionally, Microsoft may send you an email saying we need to take one of the hosts. We need to patch one of your hosts and take it offline. That might affect your virtual machines. So if we take 2 or more applications that are either clustered or network load balanced, if we put those servers into an availability set, we're able to get a 99.95% SLA from Microsoft against that service. Microsoft are guaranteeing that one of those 2 virtual machines will be available for 99.95% of the time. More recently, Microsoft have extended on that concept by introducing something called availability zones. And what they do with an availability zone is separate out where we have a load balanced application with multiple VMs or a clustered application with multiple VMs. What they've done is they've allowed us to separate that out into different facilities in the same Azure region. So if you go into the UK South region, there are 3 or 4 data center buildings there with their own independent suppliers of hardware, air conditioning, network connectivity, and obviously if they're in separate buildings, they're running on separate physical hosts with separate storage. There's very good connectivity between those buildings, so we don't see any performance impact of that separation from one building to another. In an availability zone, we're dividing up the servers in our load balanced array or our cluster to be running in different buildings and different availability zones. 2 or more servers, load balanced or clustered, running in an availability zone in Azure will give us a 99.99% SLA. It is important that we're able to articulate the difference between an availability set and an availability zone. With an availability set, we have 2 or more virtual machines in a cluster or that are load balanced, and they all run on managed disks or on storage that it is itself clustered. If we move over to an availability zone, we get a 99.99% SLA. What that means is those workloads are separated out into different facilities within the same Azure region. If you think back to the AZ-100 course when we discussed the fundamental building blocks of Azure, you'll remember that a facility is one building. If you go down and take a look at UK South or US West, what you'll find is Microsoft have built fairly close to each other separate buildings called facilities. Each building comprises, each component building together comprises into a zone. So what we're saying with an availability zone is we're just going to separate the stuff out to multiple buildings, but as well as our storage being independent, we're also going to have an independent supply of power, air conditioning, network connectivity, and obviously the hardware is going to be independent from one another because they're in different availability zone and a different building. If we want to be able to keep our virtual machines highly available, it's vitally important that we monitor them. Not only is it important for us to monitor how available the virtual machines are to keep Microsoft honest on their promises of a 99.9 or 99.95 or 49's SLA, we also need to monitor the availability of our VMs at the very least so we can see when one goes down and we can come back and take some kind of corrective action. Also as well, we probably need to report to our customers on the availability of the virtual machine and the workloads that run on it. So, built into Azure, there is a systems management and monitoring tool called Azure Monitor. What Azure Monitor does for us is it takes a look at the health of the application, the operating system, the Azure resources that the virtual machine is built on, like its virtual network, its virtual hard drive. It takes into account the health of the subscription and the tenant and the Azure regions. We can also bring in custom sources as well into Azure. All that information, logs, events, alerts, performance, and availability metrics get pulled into a set of logs and metrics in Azure Monitor that then allows us to provide insights, visualizations, analysis. We can create alerts and notifications on that. And what we can also do is integrate this monitoring as well by sending webhooks or using logic apps to forward events to other management tools, or we can have logic apps that's trying to attempt to self-heal a given resource. So when we're building virtual machines out, if we want to give Azure Monitor access to the Windows logs and performance counters and health providers that exist within the operating system, we need to install the Microsoft monitoring agent. Now, strangely enough, it's exactly the same bit of software that's used to monitor with System Center Operations Manager. It's just a monitoring tool. Don't worry though, the MMA agent has been designed to be incredibly small in terms of its footprint. The executable is less than 100 megs in size, but most importantly, it never consumes more than about 2 or 3% of the CPU or memory on your servers. By installing the Microsoft monitoring agent onto your virtual machine, you're going to extend the ability of Azure Monitor to look at the resources and fabric EVM sits on, to also bring in health metrics from inside the VM as well. Azure scale sets are a very specific virtual machine offering that's used for us to be able to create load balanced arrays of application servers or virtual desktop servers. How do these work? Well, what we do is we create an image, or we take an image from the Azure Marketplace. We then join that to a scale set. When we create the scale set, we choose the image, we choose a virtual network for it to join. We have to create a dedicated resource group for the scale set to belong to. What that means we can then do is we can load balance the traffic to the virtual machine at the back end. Because it's a scale set, what Azure will do for us is clone the virtual machine. What we've deployed is just an image. The first time we deploy it, it clones that image and creates a VM based on that image. We put in place scaling rules, auto scaling rules. So if the amount of throughput from the load balancer gets too high, what the scale set will do is deploy another machine running the same image on there. And it will continue to add additional nodes to that back-end pool or the scale set until we reach whatever capacity limits we've put on our scale set. Now, obviously, we've got to pay for each VM for all the time that it's up and running, so there is a cost to this. So in our scaling rules, we might put in a limit that says we never scale to more than 5 or 6 virtual machines, and maybe we never scale any lower than 2 just to make sure we've got high availability for it. So scale sets are all about scaling out or scaling horizontally. What that means is we'll get a duplicate of that virtual machine. We'll create extra instances of that VM. Scaling out should not be confused with scaling up, which is also known as scaling vertically. Scaling vertically is where we might resize a virtual machine or an object to give it more capacity itself. One of the things you'll find when you deploy a scale set into production, there's a subtle art of sizing these virtual machines accurately. So you don't necessarily create the biggest virtual machines when it's easy to replicate them. But what you do is there's a fine balance of the size of virtual machines versus the number of virtual machines you have. There are some limits to a scale set in Azure. Provided you've used a marketplace image, i.e. one that Azure has provided for you, you can have as many as 1,000 virtual machines in a single scale set. That means we can scale up to a dramatic amount of compute horsepower. If we've had to create a custom image, let's suppose we've needed to modify the build image and install an application into there that's not being provided by Microsoft, so not something where we've deployed some code onto a website or a .NET application, but where we need to install something alongside, like maybe a third-party component like Btrieve or Crystal Reports or something on there. And we've had to make a custom image to do that. We've got a maximum number of VMs we can scale out to of 100. And that's really Microsoft saying, look, we've created this VM image. We know it's good. We know it'll scale up just fine. This one here where you've created it yourself and uploaded it yourself, well, we haven't done any due diligence checks on that. So what we're going to do is we're going to cap that to 100 instances you can scale up to. It's really important when we create scale sets that we size the storage accurately. We have to use managed disks for scale sets, and also as well, it's highly advisable that we use the premium storage rather than the standard storage tier to size the scale set accurately. In lesson 2, we're going to take a look at the options we have for automating the deployment of virtual machines in Azure. Because Azure gives us a software-defined data center and software-defined networking, and it's very easy to provision virtual machine instances, we need to understand the end-to-end cycle of deploying an entire virtual machine with a workload on it. So, in the exam, the objective automating deployment of VMs is going to account for roughly about 1/5 of the questions you're going to see. What do we need to be able to do to answer those questions? Right, we've got to know how to modify an existing ARM template. Don't worry, we're not going to have to open a notepad and write an ARM template from scratch. Everything to do with ARM templates, we generally create one in the portal by creating a resource, download the template and modify it there to give us the customization we want. We need to be able to configure the location of new virtual machines. We need to be able to configure a virtual hard drive template. And what that will do is allow us to either have a custom image or to pre-populate image for a data drive in Azure when we attach an additional hard drive. We also need to be able to deploy a virtual machine from a template. What you'll see in the exam is you will find questions that ask you to do that through the portal, also ones that ask you to do that through a PowerShell command or through the command line interface. When you get into the labs, you're going to have a chance to do that using all 3 of those methods. Also as well, it's important that we're able to export an ARM template out of the Azure portal. The idea being is if we download or export that portal, we can take it, we can use it, we can modify it, and then potentially import it into another Azure subscription or a new tenant someplace else and reuse that template. When we're configuring the location of a new virtual machine, it's very important we get this right. Why is that? Well, if we're deploying a virtual machine and we're deploying it into a particular region, that determines where it physically sits in the world. It determines which Microsoft data center it's going to sit running. When you come to create a new virtual machine through the portal, the very first blade we'll see is the basics one. In there, we need to give the virtual machine some pretty simple and essential information, like a name for the resource. We need to choose the type of disks this VM is going to use, whether it uses solid state or whether it just uses traditional hard drives. That can obviously affect our price, so that choice there will limit the sizes that we're able to choose on the second step of the virtual machine. Azure is going to provision this virtual machine for us. If it's a Windows machine, it's going to use sysprep to automatically inject some settings into it from a sysprepped image that Microsoft have created. So Azure needs to have the answers to some questions we put in there. Like, for example, what's the name of the local admin user account it's going to create and what password is it going to have with it? Whenever we create any kind of resource in Azure, we need to tag in the subscription that will pay for that resource. So here we can see here I've used my Azure MSDN subscription to do that. Every resource in Azure needs to exist within a resource group. If you think back to the AZ-100 course, we frequently discuss the idea that a resource group is just a structuring mechanism that we use to divide up who has access to a particular resource and to logically structure our Azure resources together into something that typically describes the architecture of the solution and describes dependencies. So what we can do when we're creating a virtual machine is either add a VM to an existing resource group or add it to a new one. The other thing to look out for as well, most importantly though, is the location. Yeah, if we deploy a virtual machine in the wrong data center, we could be breaking data sovereignty regulations. We could be deploying a virtual machine in a location that there's too much network latency or not sufficient bandwidth available from where we are to be able to serve for the virtual machine to service its workloads. I've seen a number of customers where they've deployed their first couple of virtual machines into one Azure region. Then they've come along to complement some app servers that they've built by deploying a SQL Server cluster. And they've accidentally deployed the two components in different data centers. Now, the first time they've known about that is when they've come along and tried to connect the machines and they've found, well, actually they're on different virtual networks. So, and also as well, the location, as you can see by the map, could have a massive impact on data sovereignty and network latency. It's very difficult to change the location of a virtual machine. Not impossible, just difficult. So make sure you get the location right. One of the other options you see on the first page of configuring a virtual machine is to ask whether or not you already own a license for that VM. So if you already have the license for this VM, let's suppose you've bought Windows Server data center CALs for on-prem with bring your own license rights and software assurance. You can use those Windows Server CALs you've already bought for on-prem in Azure. That means you can tell Azure that you already have a Windows Server license for that VM, and it'll reduce the running costs by 40% because you've already paid for the software license. Also as well, you could potentially run your virtual machines with an evaluation license. If it's not for production use and you're only going to have it there for 30 days, you can potentially use an evaluation license to run that. So by ticking that button, you're saying that what you're actually saying there is that you're not choosing to pay for the licenses as part of your Azure spend. It brings down the amount of money you have to spend with Azure, but bear in mind, you do need to be able to demonstrate for software asset management that you have a license for this. So if you're picking this option, make sure you can justify that it is a temporary evaluation workload, or that you already have a license somewhere else that is transportable to Azure. There are lots of T's and C's about software assurance rights. There's lots of T's and C's with Microsoft licensing. If you're in any doubt at all about that, speak to a licensing specialist. If you're under any doubts, click the no option to already have a server license. It will mean your burn rate or your cost for that virtual machine is what it says on the tin. It's not going to get any more expensive. You're just not going to get that saving. But you can guarantee you're going to have a license for it. When we deploy a virtual machine, either through the portal or through the command line interface or from Azure, what we're doing is populating answers into an ARM template. When I come along and tell Azure that I want to create a new virtual machine, it clones the ARM template for that and it uses the portal or the PowerShell command line or the CLI to populate in there variables into that template that have the value we want. If you look over here at the screenshot of an ARM template, what you'll see is we have this idea of parameters. So for example, here we have a location parameter, a storage account parameter, an account type parameter. These are all things that Azure needs an answer for. These questions need to be answered for Azure to be able to provision this resource. Once we create anything in Azure, we're able to look at the properties of that resource and we can export it and save it as an ARM template. When we save it as well, what we'll download is a zip file that contains the template, a list of the parameters that need to be populated, but it will also give us a script file that we can run in the command line interface or PowerShell or even the .NET framework we could execute to make that template be deployed along with the settings we specify. What's really cool about Azure is we're able to take an entire resource group and save that as an ARM template. So if I've built out an infrastructure that has 4 domain controllers in an availability set, I have 2 SQL Server backend servers in an availability set, and I have 4 network load balanced applications in the front end, I have a virtual network, I have subnets, I have firewalls, and I've built out that infrastructure, I can save that entire configuration, that entire architecture as an ARM template and exploit that. I can then consistently redeploy that ARM template elsewhere and recreate that environment in other Azure subscriptions or other regions, or even in the same one if you really want. That's the power of ARM templates. Don't be too concerned about the contents of an ARM template file itself. For the purposes of the exam, you won't be required to write an ARM template from scratch. However, it doesn't hurt to be able to go into the portal, save an ARM template, and understand where settings are coming from and what values are being asked for it. In this lesson, we're going to describe and understand the process of deploying a Windows or a Linux virtual machine in Azure. As I said before, if you don't have much experience working with the Linux operating system, don't worry too much. The exam isn't a Linux exam. It will test your ability to create a virtual machine with a Linux image on it. It will test some very basic management information like how you administer a Linux machine through SSH and upload files to it through FTP. But this exam does not go into any depth details about particular Linux commands or the Linux user interface. It merely deals with the resources that potentially run a Linux virtual machine in our environment. So if we want to sit and pass the AZ-103 exam, what stuff do we need to know to satisfy this objective? Okay, for deploying Windows and Linux virtual machines, we need to be aware of what managed Azure disks are. We need to be able to demonstrate how to add a data disk to a new virtual machine as we create it and after a virtual machine has been created. We need to be able to understand how to add network interfaces to a machine, not only during installation, which is mandatory, but it's also possible to go back to the portal and subsequently add additional network interfaces to our virtual machines. We need to be able to automate configuration and management using PowerShell desired state configuration and the VM agent by using custom script extensions. We need to be able to manage virtual machines. Now, with some caveats, it is possible to move a virtual machine from one resource group to another. It's also possible to resize a virtual machine. Typically within the same family of virtual machines, we can resize it up and down, depending on some of the hardware constraints that are in there. It's also useful to be able to know how to redeploy a VM. Redeploying a VM is essentially saying, okay, let's take the image for the operating system that's there, let's take the hard drives that are there, recreate a new VM on entirely new hardware within Azure to guarantee we get a fresh build of this VM. It's a great troubleshooting step. Now, let's take a look at these in detail. This next couple of slides talk us through the process of creating a new virtual machine in Azure. Now, the process for creating a Windows VM and creating a Linux VM are pretty much identical, and you'll probably be able to spot for yourself the point where the process differs. Deploying a new VM through the portal is broken down into 4 steps. In this first step, we answer some basic information. What's the machine called? What type of hard drives are we using? We need to provide a local username for the local administrator account and a password. So Azure is going to stop us from putting in the username of administrator because that will already be in place in the build. It will just be disabled. So we have to use a different name. We can't use administrator, we can't use root, and we can't use admin because those usernames are easily guessed. Also as well, a password, it needs to be a complex password with characters, numbers, and it needs to have at least 12 digits in it. So it's going to drive us towards creating a secure local administrator password. Now, don't worry, if you accidentally lose that password later on, it is possible to come back to the properties of a virtual machine and do a local administrator password reset through the Azure portal. We need to choose which subscription is going to pay for this resource. Like anything we create in Azure, there's obviously going to be a cost associated with that. Microsoft needs to know which invoicing mechanism to send the bill to for this resource. Any resource we create must live within a resource group. So are we going to use a new resource just for this virtual machine, or are we going to use an existing one? Creating a virtual machine is rather a special operation in Azure because as well as creating one resource for the virtual machine, we'll also be creating virtual hard drive resources, virtual network cards, potentially public and private IP addresses will be created as well. Maybe we're creating network security groups to lock down the access to these machines as well. So it's really important, that we keep those resources structured together. Personally, I'm a big fan of having one resource group that contains all of the virtual machines of a particular application. So I'll create one resource group and all my domain controllers, virtual machine objects, virtual hard drives, and network security groups all live in that same resource group. The next step in deploying our virtual machine is to choose the size of it. So we navigate by the family or type of virtual machine. In this case here in the portal, what I've done is I've selected the DS1 version 2 standard. And you can see here that there's some sizes available to me. There's some trends with virtual machine sizing. Some things you need to be aware of when looking at virtual machine sizing. First of all, the sizes in a family of virtual machines tend to start off with one CPU, a very small amount of memory, 2 disks and 1 network card, and they will increase as you move up. So as you move from a DS1 machine to a DS2, the number of CPU cores doubles, the amount of memory doubles, and that's kind of a pattern that carries through as you get larger through the machines. Now don't worry, even though they used to be on the old exams, you will not find any questions that require you to be able to articulate how many CPUs or how much memory is in a given size of virtual machine. Microsoft realized that questions like that add no value. In the real world, when you're sizing a virtual machine, you'll use the cost calculator tool, or you'll use the TCO tool, or you'll just go and look in the pricing calculator to see the sizes of machines that are available and how much capacity you get in there. That's not something it's worth testing people on. Now what we need to do in the third step is to configure the virtual machine. Now there's a couple of different sets of management capabilities a virtual machine might need to have. So for example, have we turned on boot diagnostics? What that allows the virtual machine to do is look at the events that are happening inside the virtual machine as the machine starts up. And what it'll do is it'll write that information into a storage account for us. So if our virtual machine is trying to install and there's a problem with the Windows boot up process, because we haven't got any mechanism of looking at this machine bare metal like we had through Hyper-V or with a physical host, those boot diagnostic logs will tell us what's going on. Also as well, we can choose to enable or disable guest operating system diagnostics. It might be that we've got some sort of compliance requirement to say we can't take logs out of the operating system and put them into the underlying fabric. That's becoming less and less common now. The idea here is if we enable guest diagnostics, we get the Windows logs for storage and for the various services running, and we write those into a secure storage subscription as well. So obviously we need to identify the diagnostic storage account that we're going to use to keep that telemetry in. So what's considered to be good practice is for each family of virtual machines. So for example, where I've got VMs that are domain controllers, VMs that are SQL servers. Where I've created a dedicated resource group for those machines, I'll create a storage account in each one of those resource groups and put all of the logs for those VMs into that one storage account. As we're setting things up as well, we need to be able to configure some of the management capabilities. What used to happen in the old days was you came along, you created a virtual machine, you started running it and you forgot about it. And what happened was you didn't configure backups, you didn't recover site recovery management, you didn't install the Azure monitoring agent on there. So what they've started doing now is they've built into the Azure portal during the new virtual machine creation wizard, they'll prompt you on to make a decision about whether you want to back it up or not. What that means is when you come along and create your first virtual machine, you can put in place all the configuration needed to set up a backup vault, to set up a site recovery policy. You'll be prompted to do all that if you want to say the machines are going to be backed up or not. And then finally, in truly time-honored Windows Wizard tradition, we're going to see a summary screen that tells us all the settings that we've applied during this machine. Now at this point, down towards the bottom of the screen, underneath all the configuration settings we've applied, we'll see a couple of buttons that appear. The first one will allow us to just deploy that virtual machine as we've configured it. The other one will allow us just to export that resource as a template. What that means is rather than having to actually build something out and deploy it in the Azure portal, we can just use the portal as a mechanism to build as like a graphical user interface for building out ARM templates, saving them and exporting them. Or we can click the deploy button and it'll deploy it for us. Because of the architecture of Azure and the way it handles virtual machines, we don't have a console that we can look at and see how a machine's behaving during system startup. The only time we get access to a machine is once the Windows operating system is up and running. We can then connect to it through PowerShell, Windows Remote Management, or we can connect to it through Remote Desktop. But during the pre-GUI phases of operating system startup, we don't have any access to it at all. So if we get a problem with a virtual machine where it's not booting correctly or it's not starting up at all, we need a tool to help us fix that problem. This is where the redeploy of VM option comes along. What this allows us to do is isolate the settings in our virtual machine from the boot setup settings on the operating system from our data and configuration. If I click the redeploy button for a given VM, what it will do is shut down the virtual machine, deploy it again using the same Azure configuration for its resources onto different hardware. So it'll run on a different hardware, a different virtualization host somewhere in Azure. It'll create the new virtual hard drives again, but what it'll do is it'll use the contents of the hard drives as they were, effectively backing up the system as it was and deploying it out again. So what should happen then is the machine should start up and it should work. There's a couple of phases to this. It does take a little bit of time, but it's just the same amount of time it takes to create a VM in the first place. So realistically, you're probably looking at about a 10-minute time to redeploy a VM. Do bear in mind though, when you're redeploying a VM, it's not available. So hitting the redeploy button will take it through a process of copying, updating the configuration, and then eventually when it's up and running again, it'll show the status of running. If you look along the top of this dialog box here, we've got some control buttons for the virtual machine. The settings one will tell us to take a look at its configuration. Connect will allow us to download a file that will connect to the remote desktop protocol, or if it's a Linux machine, it'll allow us to connect through secure sockets host or FTP to upload files to it if we want. We've also got the start and restart buttons as well. So maybe if our VM's not running well and we need to do a hardware reset, we can use the restart button to do that. Also, there's the very dangerous looking delete button. This is one of the use cases where we would probably put resource locks onto our virtual machines to prevent people from accidentally deleting our virtual machine. A word of warning, if I hit delete on the virtual machine, I will delete the virtual machine instance itself. If I delete the virtual hard drives, I'll lose all the data that's on there as well. So do take careful with that delete button. One of the big use cases I use resource groups for is to logically structure the access to a group of resources. So what that means is occasionally we might have a virtual machine that changes from one team's administrative control to another. Or maybe we've deployed a VM to a resource group incorrectly. So it's entirely possible we may need to move a virtual machine object from one resource group to another. Now, it is now possible through the portal to use the portal to actually move a VM from one place to another. But it's important to understand that the virtual machine is not the only resource that comprises of the virtual machine we see. There are also virtual disks. The virtual machine object itself is essentially the configuration of the virtual machine that points to the location of hard drives and explains how much hardware it has. Other objects like the network interface, network security groups that are attached to the network interface, if it's got a public IP address and its connection to a virtual network, ideally we want to keep those resources together. So if they're in the same resource group, we probably want to move them consistently together across. In lesson 4, we're going to take a look at creating an Azure backup vault, using it to back up and to protect virtual machines, and also extending that vault so it can provide Azure Site Recovery Manager for disaster recovery and automatic failover of virtual machines. The Managing VM Backups objective is worth about 15 to 20% of the exam. That means about a fifth of the questions you're going to come up against are going to be about Azure Backup or Azure Site Recovery Manager. Let's take a look at this stuff at work. Azure Backup is a software as a service backup solution. What that means is we don't have to build any backup servers. We don't even have to configure any hard disks for the backups to live in. Essentially, the Azure Backup service is a software as a service offering that runs in Azure. It can be used to manage and protect virtual machines we have run on-prem, and it can also be used to protect virtual machines and servers that are running in Azure. So, it is possible for Azure Backup to be able to protect a virtual machine running in Azure at a VM snapshot level without putting anything inside that VM. It can do that because obviously Azure Backup can speak to the storage infrastructure and the storage resources to back it up through Azure itself. However, just being able to create a VM snapshot might not be enough to satisfy our backup requirements. Maybe we're required to create granular file backups. Maybe we've got a SQL database that we need to back up. So to achieve that, what we need to do is download and install the Azure Backup Virtual Machine Agent. Basically what we do from our Azure Backup portal, we download the agent to a machine and install it. We give it a service identifier that points it to our own Azure Backup service, and we give it a key to allow it to authenticate in there. Once the virtual machine agent is installed, we can then provide file level backups. The virtual machine backup agent also contains a small GUI that's accessible through the control panel of the machine where it's installed, and that would allow us to put much more granular configuration around particular file backups and schedules. When we use Azure Backup, what we're doing is we're taking snapshots of our virtual machines in Azure by taking snapshots from the storage and transferring them into a storage vault. So it makes sense to keep our virtual machines running in one geographical region and to make our backups someplace else. The idea being is that our backups are stored elsewhere, that way we can recover elsewhere. When I create an Azure Backup Vault, I need to make some choices. I need to choose which data center the backup vault resides in and where it's going to ship its data off to. Now, it's good practice to keep the vault in the same location as our virtual machines and allow it to replicate that storage off-site. So once we've configured that, once we've configured the vault, then what we need to do is to configure a backup policy. And a backup policy is essentially a schedule for when we take a full backup, when we take a differential backup, and also when we take a log level backup of individual files. Most importantly, within the backup policy as well, we've got our retention periods as well. So I can restore my data pretty much indefinitely. One of the great things about Azure storage is it's almost infinite. We can consume as much of it as we like, and it's not very expensive. So Azure Backup gives this quite nice archival feature in here. So maybe we're taking a backup every day at 3 p.m. But what we do is we choose how long to retain that for. So maybe what we do is keep each daily backup and store it for 180 days. Maybe what we want to do is take the backup we take on the Sunday of the week and keep that for a certain number of weeks. And then what we can do is say take the last backup of the month and keep that for 60 months. Then maybe we have one yearly backup where we take, say, the backup taken on January the 1st, so taken on the first Sunday of the year, and we retain that for 10 years. So what we can do is be quite granular here with how much data we retain. Now it's very unlikely that if we take a snapshot of a virtual machine and bring it back online 10 years later, everything's going to work perfectly, because there will have been changes made to the directory services around it. But that data will still be there and it'll still be visible. And we can also do file level backups with this as well. What I generally recommend people do with a backup policy is say, let's create one daily backup and keep that for 7 days. Then create one weekly backup and keep that weekly backup for a month. Anything beyond that really should be on a need to have basis. If we're backing up something like a domain controller, there's very little value in being able to restore a domain controller from maybe 3 or 4 days ago because of the level of changes that will have happened to the directory database. So if we do need to back stuff up and archive it for a longer period of time, we need to think about when we need to do that. The trick here is to have an archival point where we say once a month, we'll take a backup and we'll keep that for a year. Then once a year, we'll take one backup and then we'll keep that for 10, 20 or 100 years. Now at the moment, the GUI in Azure goes up as much as 999 years for retention. So this is quite a good product for long-term retention of backup data. In the real world, it's important to note that Azure Backup does provide some level of application consistency backups. But you've got to remember that as a backup tool, it's aware of the Microsoft operating system and it's aware of SQL. What it's not aware of is specific workloads like SAP or Oracle. Whilst we can back up all the files and the system configuration and the virtual machine images that SAP runs on, that's not the same thing as providing a true application recovery point. So we could use this as a way to back those machines up, but there will be extra steps involved in restoring it to a workable level of the service after we restore the backup. Restoring a virtual machine is a very simple process. What we're able to do is choose the restore point. So that is, what is the point of time where the machine was backed up that we want to revert it back to. Once we've selected that, we need to put our restoration configuration in, which is quite simple really. We can either create a new virtual machine with that data on there. And by doing so, what we can do is we can choose the restore type and say we either want to recreate the entire virtual machine, or we just want to granularly restore some files from it, or maybe we want to get a SQL instance back from it. Because we're creating a new virtual machine, we'll need to give it a new machine name object, and we probably want to put it into a new resource group as well. Now, you have to be very careful when restoring a virtual machine. If I have two virtual machines they won't have the same IP address because Azure will give the machines a unique IP address, but they could have the same host name. So it's important that when we redeploy a virtual machine, if we're creating a new one based on it, we want to avoid the chances of there being any application conflicts. So it's a good idea to do the restore of a virtual machine to another location. Then you can go into it and choose the files you want to move off. Also as well, when we're creating that new machine, we need to choose which virtual network subnet we're going to position it on and what storage account we're going to use to keep the restored virtual machine into. The alternative to creating a new virtual machine is just to replace the existing one. If we're doing a virtual machine restore, what we do is we say, well, I want that machine back, with the same configurations in place now, but I just want the hard drives to be reverted back to where they were at the restore point. The Azure Backup Engine itself is really good because it's able to work at a storage level to replicate data. And inside the operating system, it's able to leverage the Windows shadow copy server to be able to take copies of data without causing data loss. That gives us a very powerful tool for creating backups without disrupting the availability of files and workloads on the machine. If you add into that the fact that the backup vaults have got hugely scalable amounts of storage we can keep data in, and because of the magic of Azure, we're able to replicate that data to other data centers in the world quite easily. Azure Backup becomes a platform that it's then very easy to implement a full-blown DR service with. That full-blown DR service is something called Azure Site Recovery Manager, or ASR. The way Site Recovery Manager works is we take a backup of a machine, we periodically replicate, we take another backup of that virtual machine, and we replicate the backup from the local region where the virtual machine lives to a failover region somewhere else. So let's suppose we're running production in the US region. We can replicate that information across to the central US region. Yeah. Then Azure Site Recovery Manager can monitor the health of the East US data center, or monitor the health of the actual machines running in East US and detect when there's a service disruption. It can then trigger an automatic failover job that will cause the virtual machines in central US to be brought online using the latest replica of data that's available. It can work with other technologies like Global Traffic Manager and our ExpressRoute and VPNs to be able to fail over on-premises connectivity and inbound connectivity from the internet across to the other region. One of the other options that you have with Site Recovery Manager is maybe you don't want to trust the failover operation to an automated process. So it is possible to configure this that an administrator needs to come into the Azure portal and manually trigger over a failover operation. Now, obviously as well, because we can automate failover, we can also automate failback as well through Site Recovery Manager. And that can be either manual or it can be triggered in both directions. When we do a planned failover, what we do is we tell the virtual machines in our source environment to gracefully shut down and perform a last-minute replica to make sure all the data that was on that virtual machine has been replicated across into the target environment. When we recover, we get the very latest version, the very latest replica of that machine. If we do a planned failover, we may have a service outage of, say, 10 to 15 minutes whilst the replicated servers start up and DNS records change across to point to the new environment, but we won't lose any data because we've been able to do a graceful shutdown. The alternative to a planned failover operation is an unplanned failover. And that's what happens if, suppose, the entire East US region goes offline. Site Recovery Manager then will just bring on the virtual machines in central US for us, just using the latest copy of the replica. That means there could be 30 or 15 seconds worth of data that hasn't been backed up and replicated from the source environment yet. So we do have a very small window to lose some data in an unplanned failover in that event. One of the really great things about Azure Site Recovery Manager and Azure Backup is that you can extend these capabilities onto your on-premises infrastructure. So you can deploy the Azure Backup agent onto your virtual machines, and you can configure Azure VMware and Hyper-V to integrate with Azure Site Recovery Manager. So you can perform site to cloud failovers. You can also use it to use Site Recovery Manager just as a DR engine and replicate from Hyper-V running in one region to another region to give you site-to-site failover. Now, obviously as well, we can replicate Azure VMs from one region to another. So that gives us an Azure to Azure failover. During the live recording of this course, I went through some demo exercises where I showed off how to deploy and manage virtual machines in Azure. Now, to keep the size of this video manageable and small, what I've done is a separate recording of that demo. That's available as a separate video file that's available in the Microsoft Teams site. So now is a good chance to go away, break away, get that video and watch through it if you didn't see the videos being delivered live. In preparing for the AZ-103 exam, hands-on experience is vital. I can guarantee you, if you don't have hands-on experience, you will not pass this exam. Why is that? Well, in amongst the many multiple choice questions, scenario questions, evidence questions, drag and drop and hot zone questions, you're going to run into exam lab simulations. That means partway through the lab, the exam engine is going to open up the Azure portal and give you a list of tasks and outcomes you need to achieve in Azure. Your job will then be to use the portal to configure a VNet to VNet peering, or to create some virtual machines and add them to an availability set, or maybe it's add a virtual machine with a new virtual hard drive or a new network card. Maybe it's going to ask you to create some policies in the Azure portal. So a lot of the weight of results lies on being able to solve those lab questions. Get the hands-on experience. You will thank me once you've done this. So now it's time to have a look at lab 1. Go to the team site, download the lab instructions from there, and work your way through them. Please note that the lab file instructions will probably be available about 24 hours after I've completed the delivery of this module. The exercises you go through in lab 1 are designed to give you some very specific hands-on knowledge and also to make you learn some particular lessons, in some cases the hard way. Right, what are we going to get you to do in this lab? Well, the first exercise we're going to get you to do is create some virtual machines in the Azure portal and configure things like backups on them. Then what you're going to do is repeat that exercise using the Azure command line interface. Guess what? Once you've done that, I'm going to get you to go back and do the exact same thing again using Azure PowerShell. Now, by doing this process of doing something in the portal, then doing it with the CLI, then doing it with the PowerShell, I'm hoping to get you to cement 3 things. One is a solid knowledge of what's actually happening when you create these VMs. The second thing is to understand how we're using the command line interface and the PowerShell to provide answers to the questions that need to be populated in an ARM template to be able to deploy a resource through ARM. Then, what we're going to do is create and populate an availability set. Now, there's a bit of a deliberate lesson learned in here, because this is a lesson I need you to learn for real life, which is that you cannot add a virtual machine to an availability set after you have provisioned it. So in this lab, I'm going to do something quite cruel to you, where you're going to have to do a bit of extra work to make this work. I want you to learn that lesson the hard way. It doesn't take much time to learn that lesson, but I'd much rather you learn that lesson here in the labs than either A in the exam or even worse, B in a customer's environment. We're going to do the same thing again. This time, instead of creating and populating an availability zone set, we're going to create and configure an availability zone. Then, once we've done that, we're going to configure an Azure Backup Vault and configure backups to virtual machines. And we're going to configure Site Recovery Manager to replicate those machines elsewhere and to automate failover from one regional data center to its regional pair.